So let's start with the polymorphism. I'm going to start with this sample application that I'm going to call, I don't know, intro, and then polymorphism, like this. So as an introduction to a polymorphism, of course, polymorphism is going to be using inheritance. And polymorphism is also about inheritance, but I would like also to show you some things before going. So this is my main class where I have the main method. I'm going to leave it and add some other classes, just some very simple ones, and then I'm going to show you what I'm going to be talking about. Okay, let's talk about, for example, I'm having a class called shape. Okay, that class called shape means any shape, and in that class called shape, well, let's just create one simple method. Let's call it public void display. Well, I don't know. I don't have any specific things to do with that. Just display is going to display I am a shape. So I am a shape. Muhammad, can you please come in the front? Just don't go past that line, or maybe that there. If you're not comfortable being in the front, you can go in 22 if you want. Yeah, that's whatever is suitable. There's no one anyway. Yeah. Okay, so I'm just displaying something, right? And I'm going to create another class which I'm going to call circle, for example. And circle is a shape, but it's a specific shape. I'm going to then make it inherit from shape, which I should use then extends shape. And of course, by extending shape, now I have the same methods, right? Okay, what if now I'd like to do the same public, I would like to override that display, because in that display I'm going to just show I am a circle. Actually, I can add some other things, because a circle, it can has like a double what's the radius. It can have a radius. I can make it private and then have getters and setters. Well, I'm not going to go into that, okay? So just make it simple for now, because I would like you to focus on the polymorphism. What does it do? So the rest, I'm not going to get into that for now. So imagine I have circle and shape, and let's add maybe another one or two others. Let's call them like a rectangle, which also has this display. I'm going to copy and paste, and I am a rectangle. And of course, yes, it's supposed to inherit from shape. I forgot to add it. Yes, thank you. I'll just add this override just to make sure that I'm clearly overriding the display that comes from shape. Same thing here. I'm just going to be extending from shape. And now it's going to detect that this was overriding, and I'm going to add it as well. So I have now 3 classes. I'm going to add the last one. Let's call it square, which is also a shape, which extends shape. And then I'm going to paste again with this override annotation. I am a square. So for now, everything is not really complicated. Notice that there's a small symbol that tells you that, I mean, you need to be able to read this part of NetBeans, because it helps you a lot. By having a look at the class itself, just like a summary of the class, without having to look at all the details. Let's have a look at what we did before. For example, we have person, we have vehicle. I don't need to go into all these to find out what do we have. I can see that these are the constructors, these are the methods that are public, and I have a private method here. I click on vehicle, I can see these are the constructors, these are the methods that are public, this one is private, and these ones, so this one is protected because there's like some kind of a key. You can see this is protected, and these are the ones that are private. So I can have like a summary of this class. If I look at truck, for example, I can see that it inherits from vehicle, and so on. So let's just close these and go back to my square. Another, what you have is a square extends, it inherits from shape, and then it has this kind of symbol that shows you that actually it's overriding something that comes from shape. So now if I'd like to summarize, I have a shape that has just this method, and I have rectangle and a square and a circle. All of them are inheriting from this shape. Now I would like to do something. I would like to have many different shapes. So if I'd like to have many different shapes, what I need to do, I need just to basically declare this is square 1 equal new square, and I can declare rectangle 1 new rectangle, and if I need to have another circle, circle 1 equal new circle. Now why I'm doing this, I just would like to show you something, that square 1 dot display is going to be different from the rectangle dot display from the circle dot display. Just I would like to show you that it works. So let's run, and I'm going to see I am a square, I am a rectangle, I am a circle. Nothing fancy there. But what if I would like to have an array of different shapes? I don't want to have just 3. I would like to have a lot of them. I would like to have 10 of them. How can I do that? Because of, first of all, inheritance, I can do something nice. I can do something like this, because all of these are shapes, right? So I can declare an array of shapes, list of shapes equal new shape, and then I would like to have 10 of them. Oh, that's too much. Let's just have 5. So now what I'm doing this, I'm having a list of shapes. You remember with the array from long time ago, no, if it was int, for example, if I had int, then I declare an int.
Yes, I have to put a type for both sides.
It's the type of the array, right? Before, if I wanted to have an array, this is how I declared one-dimensional array. I just put the data type and put this symbol to show that this is an array, and then equal new, the same data type, and then say what's the size.
Okay, but you have for the size you have 3 classes.
Well, for now it's int, so int is just numbers. But I don't want that. I wanted to have shapes. Now if I have shapes, now you're talking about different types of shapes. Oh, I didn't get your question. What was the question again?
It's about the number of the array.
This number here, 5. Oh, it has nothing to do with I'm having 1, 2, 3, 4, 5. No, it's a number of how many shapes do I have. I would like to have 5 rectangles, 3 squares, and 2 whatever. Let's say 10. With this 10, I'm going to use 5 rectangles, 2 squares, and 3 what else? Circles, for example. So it's just for the purpose of having different shapes, but in one array. What I wanted to say is that if you remember from what we learned, is that when you declare an array, every element, let's say if it's int, all elements needs to be int. I cannot mix int and double and everything, right? Now with shapes is the same thing, but I can have I can mix those that are inheriting from shapes. I can have an array where I can have on that same array some that are rectangles, some that are squares, some that are circles, just because all these three are inheriting from shape. So they are, because these are shapes, because they inherit from shape, so it's okay to put them in an array. It still respects the condition. All of them are shapes, because an array, a circle is a shape, a rectangle is a shape, and a square is a shape. Why? Because this is what we mean with this extent. A circle is a shape plus something that I would like to add. Okay? So now what I'd like to do is that we just make a shape of 5. I'd like to have 5 shapes. But now list of shapes, I need to put something in the 0, in the position 0, and position 1, position 2, and so on. What do I want to put in the position 0? Let's say I put a circle. What I'd like to put in position 1, and 2, and 3, and 4, and 5, I'm going to put something different. Let's put them in order. 3 and 4. 0 to 4 because I have 5.
By the first line for the array, that's you mean you just create an array that's empty.
Exactly. But the data type is shape.
Yes.
It's an array of shapes.
And
yes.
Now you will put something inside.
Exactly. The same way I declare an array of int. When I declare it, it's empty. Actually, it's empty with default values for primitive data types, which are zeros. But now, because when I do this, it's empty because they have default data types for default values for class data types, which is null. It's going to be null, 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 five times. Now, what I'm going to do, I'm going to put a square here, a circle somewhere, and something, and rectangle. But but now the new thing that you're learning is that I can mix different data types, and this is another advantage of inheritance. I can group them because they have the same father, the same parents. They're all same children of shapes, and it can go around even if somebody is a child of another child and so on. Since they're all the same thing, I can group them all. Hence, with the same logic, because everybody is inheriting from object, I can do something like this. But it doesn't work because there's no object, it's just object. Well, if you spell it right. Why? Because I have I wanted to draw something. Not this one, graphics, and this one. So what I'm having here, this is object. Object is the superclass of every class. So I declared shape, and I did not say that it has any superclass, but of course, by default is shape. Now inside that shape I had different classes. I'm not inside. I have like different classes inheriting from shape, which is the rectangle, the circle, and the square. All of these are inheriting from the shape. So the result of that is that I can, because a shape is an object, a circle is also an object because it's a shape that is an object. So it's the same thing. I can group them under this data type. But now let me show you something. If I keep them like, let me just lower this down. If I keep them like this, even though I initialize them, look what happens if I do something like this 0 dot. What do you see here? Are the methods coming from where? From object. Because I said that this is an object. Of course, this is a circle from an object, but this is an object. If I want to use this, I need to convert it. Then c dot, I can use now display. But now you can see, how can you put an object into a circle? It's not possible. I need to convert it. And this is the forced conversion. I converted, but I know actually I'm doing the right thing, because I know that in 0 it's a circle. If I do, for example, for this is going to become an exception. It's a problem. It's not possible, because how can you put a square and make it a circle? They're all on the same level. They're not inheriting from each other, so it's not possible. So let's go back to what I initially wanted to do. I wanted to have different shapes, so let's put them shape, and then I know that I can do something with shape because all of them are shape. And remember, the shape, all of them has this display. So if I'm using display, so if I'm using this list shape of 0, that I'm going to see display plus the other thing that comes from object. So if I'm using this display, this is going to display what? I am a circle. And if I change it to 3, I am a square. This is something that is quite unusual, because this data type is shape, and this display is coming from another class, not from shape. And this kind of things this is what now we can say that display takes multiple form. Sometimes it's a display that comes from a shape, sometimes it's coming from a circle, sometimes it comes from different classes. Sorry? Exactly. So the thing is, this is also called like some kind of dynamic binding, as opposed to when I'm doing something like this, circle, C equal new circle, and I put something like C dot display. I know that this display is coming from the class, no, the class circle, for sure. But now, if I do something like this, I'll have to check which index so I can tell you which class it belongs to. So the computer is going to have this binding of this method to the object only when it runs. So it will know, okay, this is normally a shape, but at this 3, okay, this is a circle, this is a square, this is what? This is.
For the circle C equal new circle.
Yes.
This will take the 0 or the 3.
It will, for this one?
We have 3 circles there.
Here?
Yes.
Okay.
Which one it will take?
Well, if you say this list of shape 3, which one is this of shape 3? So this one, right?
Yes.
This one, what's inside of it? A square. So it's not going to show a circle at all.
No.
This is going to display.
The up one.
For the first one, it's going to display. There's no option. In a circle, there is only one method called display, and if I go inside of it, I'll find it's going to display I'm a circle. But for the others, it depends on how it was initialized. If I remove this, can you tell me what is going to be the result of this one? You don't know. You don't know, because it was not initialized. Let me even show you something even more interesting. What if I use a for loop from this until this list dot length? Remember this dot length, right? Now what I'm going to do, I'm going just to display list shape of I dot display. So now look at this thing over here. This display here belongs to a shape, but the shape is not always going to be showing me the shape. It's going to be sometimes be a circle. This display can be sometimes from a circle, from a square, depending on what? Well, depending on this index, it's going to display a different kind of information because it belongs to a different kind of object. And this is called late binding. So I don't know what this method is going to be bound to, not to be attached to. It will be known at runtime when I'm going to be initializing this. But before, I have no idea. So let's run this, and I can see a lot of different things. It's going to show me this is a circle. This is the first one. Let's just remove this, so we don't need it for now. So I am a circle, I am a square, I am a circle, I am a square, and I am a rectangle. But this display actually comes from different classes, different methods. These are different methods, but this is one method name, but it takes multiple forms. This only works with inheritance and overriding. Polymorphism requires inheritance and and overriding. Look what happens if I remove this. If I don't have I am a shape. I have this public shape here. First of all, it just tells me, well, you say override, but there's no override. Let's remove this. I don't care. So just to fix these things, let's remove them. So now I'm fixing these mistakes quite easily. Okay, I'm not overriding anything because there's no display in my superclass. Remember, I just removed the display from here. This is not possible. This line is not going to work. Why? Because this list of shape was its data type. Shape. And shape does not have display, so you cannot write something like this. So it needs overriding. So overriding is necessary to have that. And of course, overriding is attached to inheritance.
That's why it changed this display.
You change it to what?
No, the main class.
What do you want to put?
Shape.
Huh? Shape is a class, not a method.
No, what if I change it to object?
Tell me what to write. What do you want to do?
Object.
What should I write? Instead of this line, you want me to do what?
Instead of the display.
Inside of the display.
Yes.
But which one? In which class? In which class? Here.
In the main class.
Which? In the main class? There's no main class, but this is the class that has the main.
Okay.
So what do you want me to do? Just tell me exactly what you want me to do so I can understand, because I'm not sure.
First line, shape.
In the first line, yes? Inside of this, I can put object. That's your question. What if I do something like this? That's even worse. I cannot have display because there's no display in object. Let's read the error message. Cannot find symbol. What symbol? The method display. Where I cannot find it? In the class object. If I go to class object, if I look here, do I have something that says display? No. But I have something that says equals, finalize, get class, whatever. If I use get class, it's going to be okay. Because it exists in the class itself, in the object. But that's not what I want. I would like to display something that comes in the subclasses. I cannot do that if my superclass in which I'm inheriting does not have this method. So polymorphism makes a method can take multiple forms, but it requires overriding. And overriding works with inheritance. Yes?
Another question. That's why make directly from the subclass.
When you make directly from a subclass, okay, that's fine. If you make it a circle, then you cannot use different kinds. You say, okay, this is wrong. This is a circle. Now you're trying to put a square into a circle. It's not possible.
Other circles are okay.
But other circles are okay, because the circle in a circle, that's fine. So this is the example of polymorphism. The idea of polymorphism is what? Having like one method that seems to be used the similar, that if you read the code you might think this is just one method that is called, but actually we're calling different methods depending on the kind of inheritance that exists between the values that you instantiated. Okay? So what I'd like you to do as an exercise, just try to do something like this. Okay? Create this shape, circle, rectangle, square. Call a method, decide what kind of method you would like to use, give it any name you want, but then use overriding to override them in the others, and in the main do some kind of an array and some kind of loop that calls that method that you've designed. Okay? Let's do that, shall we?